Hello and welcome to this video. Today we're going to talk about electrical engineering. We're going to understand the terms electricity, current, voltage, and resistance. We're going to see what is the Ohm's law and the application of this law in solving real-world problems. A short introduction about basic electrical theory. Electricity is everywhere. It lights our way, it cooks our food, and can even brush your teeth. It saves life. Many lives have been saved due to the electrical devices like defibrillators, pacemakers, etc. It powers our houses, our PCs, laptops, mobile phones. Industry is highly dependent upon reliable power sources. Almost every home on the planet is powered by electricity. Without electricity, we would be watching TV in the dark. So, what is electricity and where does it come from? More importantly, why is carpet, socks, and a doorknob a bad combination? In its simplest terms, electricity is the movement of charge which is considered by convention to be from positive to negative. No matter how the charge is created, chemically like in batteries or physically, from friction from socks and carpet, the movement of the discharge is electricity. Understanding current, voltage, AC and DC. This flow of electrical charge is referred to as electric current. There are two types of current, direct current or DC and alternating current or AC. DC is a current that flows in one direction with constant voltage polarity, while AC is the current that changes direction periodically along with its voltage polarity. Thomas Edison and Alessandro Volta were pioneers in DC current and wrote much of electricity's history. But as societies grew, the use of DC over long distances became too inefficient. Nikola Tesla changed all that with the invention of alternating current electrical systems. With AC, it is possible to produce the high voltages needed for long transmission. Therefore, today, most portable devices use DC power, while power plants produce AC. Fundamental law in electrical engineering, it states that voltage is proportional to current multiplied by resistance. In short, V equals R times I. This is the definition of the Ohm's law. And it is the most fundamental law of electricity. The V stands for a voltage, which means the potential difference between two charges. In other words, it is a measurement of work required to move a unit charge between 2 points. When we see a value such as 10 volts, it is a measurement of potential difference between two reference points. Normally, the 2 points will be positive 10 volts and 0 volts, also known as the ground. But it can also be difference between positive 5 volts and negative 5 volts, positive 20 volts and positive 10 volts, etc. In the field, you might heard the term common grounds, which refers to each device in a system using the same 0-point reference, or ground, to ensure the same potential difference, or voltage, is applied throughout the system. The next component of Ohm's law is current, the units of which are amperes. In the formula, current is represented by the very logical choice of the letter I. As mentioned previously, current is the measurement of the flow of charge in a circuit. This leaves us with the letter R, which represents resistance. Electrical resistance, measured in ohms, is the measure of the amount of current repulsion in a circuit. Simply, resistance resists current flow. When electrons flow against the opposition offered by the resistance in the circuit, friction occurs and heat is produced. The most common application for resistance in a circuit is the light bulb. The light bulb introduces enough resistance in a circuit to heat up the filament inside, causing light to be emitted. Resistance in a circuit can also be helpful when needing to alter voltage levels, current paths, etc. Resistors are self-contained packages of resistance that can be added to a circuit and are commonly used to divide voltage levels. Before we get into the use of Ohm's law, I want to introduce a few other circuitry concepts. First, we need to understand what series and parallel circuits mean. Series circuits are those which are connected in line with the power source. The current in series circuits is constant throughout, but the voltage may vary. Parallel circuits are those which branch off from the power supply. The total current supplied from the power source is divided among each of the branches, but voltage is common throughout. You have probably experienced the pain involved with installing Christmas lights only to realize none of them work. There is probably one light bulb somewhere in the hundreds that you hung up. More than likely it is because one of the lights decided to break or burn out, and because they are wired in series, the rest are now out as well. Since all of the lights are in line with each other, if one goes out, it causes an open circuit at that point, and no current will flow to the other lights because of the open circuit path. Fortunately, a lot of new light strands are wired in parallel. Therefore, if one of the lights go out, then only that branch of the circuit will be out. The open will be isolated to that branch, and circuit will continue to the other lights in the strands. Application of Ohm's law. Let us calculate the voltage and current supplied to each loop. The schematic shows a supply circuit for a child's bedtime toy. R1 is represented as the resistance of the speaker, and R2 shows the resistance of the LEDs. R1 is equal to 430 ohms and R2 is equal to 284 ohms. And the supply is a battery with 5 volts DC and 5 amperes of current. What is the voltage supplied to the LEDs and the speaker? First, we need to find out the current in the loop once the belly is pressed and switch 1 with S1 is closed. The supply offers 5 amperes of current, but the circuit will use only what is demanded by the loads. Using Ohm's law, we can reconfigure the formula to solve for current in the loop for I loop equals to voltage of the loop divided by the resistance of the loop. We can calculate that the current of the loop is equal to 7 milliamperes. Now we can find out what is the voltage required for the loads for the speaker and for the LEDs. For the speaker, it's simple. We just need to multiply the current of the loop with the resistance of the load, and that is equal to nearly 3 volts DC. And the voltage of the LEDs is near 2 volts DC. This circuit is known as the voltage divider circuit. The supply voltage was divided among volts in proportion to the resistance each load carries. R1 had a higher resistance and received 3 volts of the total 5 volts DC, and R2 received the rest of 2 volts DC. It can otherwise be stated that R1 has a voltage drop of 3 volts DC, and R2 has a voltage drop of 2 volts DC. In a more complex circuit, the combination of the Ohm's law and Kirchhoff's law is essential to solve those circuits, like in this example of a toy car remote control unit. Thank you for your attention. This was a short introduction to the Ohm's law. For more information about application of the Ohm's law in advanced circuitry, you can browse the internet. I hope it was easy to understand. Till next time.